Alright guys, so I'm going to go through your Unit 3 FRQ test study guide here. Let's go ahead and get started. So just so you guys know, numbers 1 through, I think it's numbers 1 through 3, I was kind of intending to go over these, and then my hope is that you guys would handle the rest of it on your own. Now I will go over the entire worksheet here. However, it's not going to benefit you very much if you don't try to do numbers 4 through 10 on your own. I'm just doing the video in case you get stuck on those or if you have a question afterwards, but I would highly discourage you from just watching the video and copying down what I write. You want to take a moment, try to work them out on your own. But numbers, and the way it's set up is if you can do numbers 1 through 3, which I'm going to go over in the video here, you'll have a pretty good understanding of how to hit up 4 through 10, okay? Because 4 through 10 are meant to mirror numbers 1 through 3, all right? So that's just my recommendation, but ultimately I'm going to leave it up to you guys to work on it however you need to. All right, so let's begin here. So number one of our FRQ questions you guys can expect to see on this test will be to show that a piecewise function is continuous at a specific point. And just so you guys know, the point that it's going to be continuous at, or not, will always be the point that is where they're connecting at. That's kind of just what I'm really concerned about, honestly. So let's begin. So to show that it's continuous, the first thing that we'll need to do is we'll need to prove that the function exists. And when it comes to piecewise functions, we also need to show that the limit exists, but the way that you do that is by finding the limit from the left and the limit from the right. I'm going to give you guys some pointers here about how to write your work. I just finished grading your Unit 3 Quiz 2s, and I found that some of you guys left this f of x off when you wrote your limits. You want to not do that. I ultimately decided to go ahead and give credit for it this past time around on the quiz, but I think that we're pushing our luck with that because I just don't know if the College Board would accept that or not. So make sure you don't forget to actually have those expressions there. Others of you guys actually didn't even write this at all. You just plug 0 into this equation, in which case you're not really demonstrating that you know you're supposed to find a limit at all. You're just plugging things in. So you have to show what you're doing. And so you definitely want to start off this way. Now, not too many of you guys did this, but I do want to caution you against this. You don't want to start by making them all equal, because they may not be. And I did see one person when I was grading our quizzes who made all these things equal, and then at the end, they weren't equal, but they left this statement up here like that. Well, that's a false statement now. So you got to be careful with little details like that. For that student, I also just went ahead and gave them the benefit of the doubt because at the end they had the right conclusion anyway. But once again, I really don't know how picky the College Board will be about that. That's something that's kind of up in the air and hard to tell. So anyway, this is a good place to start. You want to start by finding the value of your function and the value of the limit from the left and the value of the limit from the right. So the value of the function is you're going to use the piece that has an equal sign attributed to it. And so we're going to do this. All right. So we're plugging 0 in into the 1 minus 2 sine of x function there. Now sine of 0 is 0. So since this is 0, 0 times 2 is 0, and we're going to be just left with 1. Okay. Now, if I'm approaching 0 from the left, which is this next part here, I'm going to be plugging 0 into the top again, because when we're approaching 0 from the left, I'm looking for where x is less than, and that's actually the same one there. So, lo and behold, we're just going to get the same answer again. So that's nice, because it's the same expression. But if I'm approaching 0 from the right, that's where x is greater than, and so I'm going to use this. So for this one, we're going to plug in 0 to this piece here. And by doing that, we end up with 1 also, because 0 times anything is 0, and any number raised to the 0 power is 1. So now we can put our equal signs in there. But don't do it until you're sure they're all equal, okay? So just kind of reviewing the things again. And by the way, some of you guys didn't even bother stating all the three parts. You have to state all three parts. Some of you guys just did the limit from the left and the right. But as you guys know, a limit from the left and a limit from the right matching doesn't mean the function exists there, and that's a discontinuity. So you have to show the function exists also if you want to prove that a function is continuous. So you have to have all three parts. Make sure you don't put equal signs in the beginning until you're sure they're equal. And then thirdly, don't forget to put your f of x there next to the limit symbol. And don't forget to do the whole limit thing also. Don't just do the math where you're plugging numbers in. Okay. So this is how you want to show your work. But, oh, and actually some of you guys left off another thing here. And this, you know, everybody left off different little pieces here and there. And so I'm just coming up with ideas of things to share with you. I almost forgot this part. You have to actually state your conclusion. So we say, therefore, f of x is continuous. Don't forget to state your conclusion. Some of you guys did this, but then you didn't state a conclusion. It's like, okay, you have to tell people what that means. Well, that means that it's continuous. And I know what you're thinking. You guys know what I mean. And I totally agree with you. I do. But I need to get you guys ready to know how they will grade you on this exam, and they will not give you credit for that if you don't state your conclusion. Gotta have that conclusion stated. Let me go ahead and move on to number 2 here. All right, let f be the function defined by f of x is equal to this. And let g be defined by the graph below. So this is the g function right here. And this is f. So we have two different functions we're looking at right now. We have f and g. F is given as an equation and g is given as a graph. They want us to find the limit of f of x over g of x as x approaches 0. All right, well, let's go ahead and do that. So the limit as x approaches 0 of f of x over g of x. The first thing I'm going to do is I'm going to try to do some direct substitution. I'm just going to plug 0 into both of these. Now, g of 0, that means what is the y value when x equals 0? Well, that's 0. And f of 0, that's going to be e to the 0 times sine of 0. And this equals 0, this equals 1, and 0 times 1 is 0. So we end up with an indeterminate form. So I don't want to put equal signs. I'm going to put arrows here, okay? So we're going to say, therefore, by L'Hopital, okay, so already you want to make sure you're showing some things. You need to show that you get an indeterminate form, but don't put equal signs, put arrows. Then you need to say, therefore, by L'Hopital's, and then you need to write this. You need to write the original function first. And then you need to put the next part, which is the result of L'Hopital's conclusion, which is that you can take the derivative of the top function and the bottom function and try again. Okay? Now, let's go ahead and do this. So, we need to find f prime of x. So, first thing I'm going to do is I'm going to find the derivative of this expression up here, and that is a product rule. So it's a, b plus a, b. I'm going to let a represent the e to the x and b represent the sine x. So it's going to be a prime b, ab prime, right? That's the product rule. So the derivative of e to the x is just e to the x, and b is sine x, a is e to the x, and b prime, the derivative of sine x is cosine x. And now, once again, we want to do our direct substitution. So let's plug that 0 in. Oops, wrote that wrong. Write that. There we go. Okay, I wrote it over here like that too. Silly Mr. Bailey. All right. There we go. Okay, so e to the 0 is 1. Sine of 0 is 0. E to the 0 is 1. And cosine of 0 is 1, not 0. And so that's gone, and we're just left with 1. So the top of this answer is 1. Now notice I put equal signs. That's kind of dangerous, so maybe I should wait a second on putting my equal signs, because what if we end up with another indeterminate form? Let's be careful with that. But anyway, I know the top is 1. Now let's do the bottom, g prime. Now this is something that a couple people struggled with back in our Unit 1 test. The graph of g is what we're looking at here. Now g represents the y value, as I said earlier in this video. But g prime represents the slope. So what is the slope of this line at that point? Well, all you have to do is do a rise and run. So it looks like it goes over 2 and up 3 to me. So that would be a slope of 3 over 2. Okay? And since this is an FRQ, you don't need to simplify this. You can just leave it. Okay? And I would if it's weird, because, you know, every step we make is another opportunity for a boo-boo. So we got to be careful. So what are the important things that you want to show here? First of all, you need to show that you get an indeterminate form. You need to state, therefore, by L'Hopital. You need to state that the limit of the original is equal to the limit of the derivative, and then you need to have the answer. Now, this stuff over here, honestly, as a grader, I would be really uncomfortable giving credit for your answer here in the numerator if you didn't show that work. So I would encourage you guys, if you have any kind of math that you need to be showing, that you show it. I mean, we shouldn't be assuming. You don't want your grader to think, well, man, either this guy just didn't show his work, or I'm wondering, did he cheat or something, right? So you want to make sure you show your work. But this part over here is actually questionable whether it would matter or not. Maybe you could actually do that in your head, and they might just give you the benefit of the doubt. But I would say for this particular problem, these 4 pieces are definitely essential. This one, I would recommend you do show your work, though. Okay. All right. So I just want to reemphasize one more time before I leave this problem that g prime represents the slope of this line at that point. Okay, so all you have to do is do a rise and a run. And don't forget, you know, if the line is sloping upwards like this, it's positive. But if it's sloping downwards, that would be a negative one. So you got to be careful with that kind of stuff. Remember, people struggle with that in our Unit 1 test. All right, let's go ahead and take a look at number 3 here. Okay, the table below gives selected values of the function f of x. The function f of x has discontinuities at x equals 2 and 5, but it's continuous everywhere else. So, let's see. Can it be shown that there is a value c such that f of c equals 5 on the interval from -3 to 0? All right, well, we've been here before, right? This looks a little bit different this time because we're using a table instead of an equation. So let's see if we can figure out how to do this. So when you're doing this, the first thing you want to do is you want to make sure that it is continuous. And it has to be continuous only on the interval that we care about. So they want to know, is it continuous on this interval? Well, according to our instructions up here, the only discontinuities that exist are at 2 and 5. So are either one of those numbers on this interval? And the answer is no. So since those discontinuities are not on the interval, then the answer to our question here is yes, it is continuous, so we're fine. All right, let's go ahead and move on to part B. The next thing that we do is we ask ourselves, head scratching here, I'm trying to remember how I taught it to you guys. I think what I asked you guys to do, actually the first thing was to identify A, B, and K, wasn't it? I skipped that, so let me go backwards a little bit, because I know that the way I taught you guys originally, the first thing I said was identify A, B, and K. So let's do that. Back up a little bit. My bad. We'll call this B then. All right, step A. So for step A, we need to know what A equals. We need to know what B equals. and we need to know what k equals. Okay, now a and b are the numbers of your interval. A is the lower one, and b is the higher one. K is the one that we're trying to get f of c to equal, so in this case, k equals 5. All right. All right, step C. After you identify what a, b, and k are, and after you determine if it's continuous on your interval, the next thing you want to do is you want to find out what is f of a. Got to be careful. Is that what my function is actually called? Is this function actually called f? Yes, it is. Be careful with that. Don't use the wrong function name when you're doing these problems, because once again, one of those little things they'll get you on. All right, so f of -3, what is that? Well, at x equals -3, f equals 4. So the answer for that is 4. What about f of b? F of b would be f of 0, and f of 0 is 9. And then part D is we just want to make sure that our k value is actually in between those. And sure enough, 5 is in between those two things. So we're good to go. Now we're ready to go ahead and we're ready to write out our little statement here that we like to say. And here's how it goes. Since f is continuous and goes from 4 to 9 on the interval, -3 to 0, there must be some value c that f of c equals 5. And there it is. That would be our final answer. Now, whenever I was grading your quizzes, some of you guys worded a little bit differently, which I don't mind, but what isn't going to work is if you don't state everything that needs to be stated. You do need to state that the function's continuous. Somehow, you need to state the interval, and you also need to somehow say that your k value is in between your two f of a and f of b values. And for me, I don't even directly state that, but it's kind of implied through the way I'm writing it. So, but anyway, just make sure you have those 4 components in there. Anyway, so let's go ahead and move on to the next part there. Let's take a look at part B. All right, so for part B, we're going to just be following the same steps here. So for part A, we want to know what is A, we want to know what is B, and what is K. In this case, A is -3, B is +3, and K is 5. For part B, is it continuous on the interval? In this case, and sorry about my nasty handwriting here, guys. I'm doing this one from home, and when I can't write on my fancy little whiteboard I got in my class, I'm just using my finger on my screen, so it looks kind of ugly. But anywho, is it continuous on the interval? Remember, it said we have discontinuities at x equals 2 and 5. Are x equals 2 or 5 on this interval? And the answer is yes. In between the number -3 and 3, x equals 2. So there 2 is between those two numbers. So there is a discontinuity on that interval. So unfortunately for this one, we're going to say no. So the answer is, can it be shown that there's a value c such that f of c equals 5 on the interval -3 to 3? And the answer is no. And we have to write our answer out because f is not continuous on the interval -3, 3. You could even get more specific and you could state where it's at. We could say there's a discontinuity at x equals 2. Okay, so there's that one. Now on the quiz from, I think it was last week we took that quiz, you either could have said it's not continuous on this interval, or you could have just told me no because there's a discontinuity at x equals 2. To be safe, though, you can go ahead and just say both. All right, let's go ahead and take a look at part C. can it be shown that there is a value c such that f of c equals 10 on the interval from -3 to 0? Well, I don't know. Let's see. So, well, here's my A, here's my B, here's my K. Is it continuous on the interval? I'm not going to be showing my work so much here on the side. I'm just going to go through the steps. So step 1, identify the A, B, and K. Step 2, is it continuous on this interval? Well, we answered that earlier. Yes, it is. The discontinuities are not on that interval, so we're good. So it's continuous, so that's not a problem. But after that, we go ahead and see if we can find out what f of A and f of B are. So f of A is this, and f of B is this. So that's going to be 4 and 9, which we established earlier. And then step D is we want to make sure that our K value is in between there. Is my 10 in between these two numbers? The answer is no. So we're going to say, no, it can't be shown that there's a value C such that f of C equals 10. So we're going to say no, and our answer is going to be because 10 is not between. Now you could either say 4 and 9, or you could say f of -3 and f of 0. It doesn't really matter. What you can't say is just 0 and -3, because those are x values. But if you say f of -3 and f of 0, those are y values. Okay, so you can either give the actual y value or the symbol that represents it. Don't just put -3 and 0, because those are x values. We're talking about y values in this statement. Okay, and for part D here, it says, on what interval can it be shown that f of x crosses the x-axis? And we're being asked to justify our answer. Well, if we're crossing the x-axis, let me draw a picture here for you. Anytime a function crosses the x-axis, the y value equals 0. Okay, in other words, the f of x value. So if I'm crossing the x-axis, that means y equals 0 or f of x equals 0. So on which of these intervals would I have to cross 0? Well, from here to here, going from 4 to 9, 0 is not in between there, so I don't necessarily have to cross 0. Going from 9 to 10, same thing. 0 is not in between 9 and 10. It's not between 10 and 8, but 0 is between these two numbers. So let me clear that up a little bit. So 0 does exist between these two numbers, positive 8 and negative 5. So that means on the interval from x equals 6 to x equals 9, yes, at some point my function would have to cross the x-axis because it goes from a positive to a negative. You want to make sure that your discontinuities aren't on the interval though. So I have a discontinuity at x equals 2. That's somewhere on this interval. That's not a problem. And I've got a discontinuity at 5. That's somewhere on this interval, but that's not a problem either. Since we're on from 6 to 9, it's continuous on that interval. And so since it's continuous and I'm going from a positive 8 to a negative 5, that means yes, it has to cross the x-axis. So we're going to go ahead and put on our answer here. We're going to say, yes, since f of x is continuous on the interval 6, 9, and goes from 8 to negative 5 on that interval, there must be some value c such that f of c equals 0. In other words, the function crosses the x-axis on that interval. And that's it. Okay, so let's move on. That's 1 through 3. Now, that's just meant to be of help to you guys so that you guys can do numbers 4 through 10. And I would highly encourage you guys to do numbers 4 through 10 completely on your own first, and then just use the video to check your answers. But at this point, I will start going over them so you guys can see if you needed help with anything, you'll have a reference. So let's go ahead and go through 4 through 10. So numbers 4 through 6 are like the first question I gave you. So I'm going to go ahead and jump in here. We're going to be plugging in -2 here. All right, if I want to find the actual function value at -2, I'm going to use this piece. So the answer is just -2. The same thing is true if I'm looking for where x is greater than -2, where that means I'm approaching from the right. So this one's also -2. Let's go ahead and do the one where we approach from the left, though. So if I'm approaching x or -2 from the left, then I would be using the top piece. So let's go ahead and plug in -2 to this. Got to be careful with our signs here. There's a lot of negatives all over the place. So we have -4 plus 8 minus 5. -4 plus 8 is 4, and 4 minus 5 is -1. Uh-oh, these are not equal to each other. So here's what I would say then. Why is, now we have to actually give our answer and a reason now. Now, honestly, I think this is good enough for a reason. I will give you credit for that. But I'm still going to show you another way to write the answer, and I would encourage you guys to just do your best to include that if you can. But I think they would probably give you credit for this as being your reason. So the answer is no, it's not continuous at x. Now, what's our reason though? Well, it's not that the function doesn't exist. The problem is that the limits don't exist because the limit from the left does not equal the limit from the right. So the real answer would be because the limit as x approaches -2 does not exist. Okay, that would be a more thorough reason, but you do need to show your work, okay, regardless. And so whether or not you state this extra little fact up here is up to you. I'll still give you credit for this here, but I would say to be safe, you might want to include that in your answers. Develop the habit now, because on the AP, you hate to do all that and leave that off and have them decide that's a year they're going to be grumpy about that kind of stuff. So, all right, let's go ahead and take a look at number 5 here. This time we're approaching -3, so we need to find out what is f of -3. We need to find out what is the limit as x approaches -3 from the left and from the right. All right, so for f of -3, I'm plugging in the place where x actually equals -3, and so that answer will be 3. And that's also where x is greater than 3, so that will also be the one where I'm approaching -3 from the right. So the answer for this one will also be 3. So now I just need to do the one in the middle there, where I'm approaching -3 from the left, and for that I would use this because that's where x is less than -3. And so here we go. I'll plug stuff in here. So I end up with 3 halves plus 3 halves, which is 6 halves, and that's 3. All 3 of those are equal. And therefore, we would say, yes, it's continuous. At x equals -3. And once again, this could count as your reason, but it would probably be better and safer to include that plus an additional explanation where you say, since f of 3 is equal to the limit of the function at x approaches -3. Now, I'll give you full credit if you just say this. Again, I don't know what the College Board will do, so let's develop a good habit now and make sure you include that just for that. All right, let's go ahead and do number 6. Here we go. So this time we're approaching a +3, so f of, and you got to watch those signs. All these are f, so I'm safe. I love it when they just use f, but they use a different letter. We got to make sure we include the right letter. They have been known to take points off. All right, find the limit from the left and from the right also. Okay, f of 3. So I want to find the place where x equals 3. Did you notice something there? There isn't one. You know what that means? F of 3 doesn't exist, and there's our answer. So the answer is not continuous at x equals 3, since, and quite honestly, I would just draw an arrow to this and circle it. That's good enough for me, because the function doesn't exist at that point. So, giving you every kind of variation I could think of there. So you'll see something like either number 1, 4, 5, or 6 on your next FRQ test. Okay, here we go. A table containing selected values of f and f prime is given below. The function f of x is continuous everywhere except at the places indicated in the table. The graph of g is provided below as well. All right. So this function is continuous everywhere except for where at x equals -2. Okay, so we'll keep that in mind. All right, so let's take a look at number 7, and we'll see what it is. All right, so this one's made to look like the number 2 that I did for you guys earlier. So as you can tell, what's going to happen with this problem is we're going to try direct substitution, and it's probably going to end up being 0 over 0 or something like that. So let's see if that's true. The limit as x approaches 6 of g of x over f of x. Now let's see what that is. If I were to plug 6 into g and f, let's see what those things come out to be. Now f of 6, as you can see, is 0. So there's my first 0, so it's already undefined. And g of 6, the y value at that point, is also 0. And sure enough, we got another L'Hopital situation. Now I'm assuming that it's just going to work here. But let's see. Sometimes you do have to do L'Hopital twice. I'm running out of space, so I hope it's not one of those problems, but we'll see. All right. G prime of 6 and f prime of 6. So let's take a look. F prime of 6 is 2. So I'm going to do the bottom first. G prime of 6, and remember, on a graph, that means that's the slope of your line at x equals 6. So at x equals 6, it looks like I'm going over 1 up 2, and that's a positive slope. So it's positive 2 over 1, which is 2, and that's a good answer, so it can equal it. It's not a undefined term, so I'm going to put my equal signs in there now instead of arrows. And my final answer can be 2, but why not just make it 1? That's not hard. We can handle that. All right, so there it is. Once again, whenever you guys do these L'Hopital problems, you have to show that it becomes an indeterminate form. Good idea to state therefore by L'Hopital. And then you want to make this statement here, and then have your final answer. Okay, those are the 4 things that are going to be essential to get credit on that problem. All right, let's go ahead and take a look at number 8. Oops, wrong color. All right, can it be shown that there is a value c such that f of c equals 1 on this interval? All right, so this is an IPT question, right? We know we have to start by identifying our a, our b, and our k. The next thing we want to do is make sure that it's continuous on the interval. So is it continuous on this interval? Well, let's take a look. We're talking about the f function, right? So when we're talking about the f function, it has a discontinuity at -2, but the interval I care about is right here. So this is not on that interval, so we're good to go. So this is a yes, it is continuous. Next, we need to find out what is f of 1 and f of 4. Let's see what those are. F of 1 is 4, and f of 4 is 2. And the question is the number 1 in between those two numbers? And the answer is no. So it cannot be shown. So let's go ahead and write out our conclusion there. I don't like how that got weirded out. Let's try that again. Okay. So since 1 is not in between f of 1 and f of 4, we cannot use the IVT to show that there is some C on the interval 1 to 4 that there you go. Since the number's not in between those two, we can't use the IVT to show that that's true. All right, let's go ahead and move on to number 9. Okay, can it be shown that there is a value C such that f of C equals 3 on the interval? Well, it's the same question. I hope you guys know. The only difference is they've changed the K value. And so, you know, A, B, and K are still the same except for K, I guess. And then it's still continuous on the same interval. And we already know that f of 1 was 4. We already know that f of 4 was 2. And is my K value in between these? The answer is yes. Now it actually works. So now we can say, since f is continuous, goes from 4 to 2 on the interval 1 to 4, there must be some value C such that f of C equals 3. All right. There's that. One more question. We'll be all done. All right, number 10. Can it be shown that there is a place where f of x crosses the x-axis? So this is like the last part of question 3 that I did with you guys earlier. So the first thing we want to do is we want to just look at the y values only. So I want you to understand we don't care about the primes for this. I'm going to get rid of them. They don't matter. I want to look at the f values. I want to know, does f of x cross the x-axis? And that means where y equals 0. So now if I'm going from, on this interval here, from -5 to 2, does the y value have to cross 0? Well, that doesn't even make sense because there's nothing here, so we can ignore that. How about from here to here? Well, same thing. That's not really a viable interval because we have a discontinuity there. So we'll ignore both of those. That's all irrelevant. So these ones all are no good. Let's try from 1 to 4. How about from 1 to 4? If I go from 4 to 2, does y have to equal 0? Nah, it doesn't. No good. How about from 4 to 6? Well, from there to there, I'm going from 2 to 0. So can it be shown there's an interval where f of x crosses the x-axis? Well, that's kind of almost a silly question because the answer is right there. Yes, it does touch the x-axis somewhere. I'm going to show you guys 2 ways to answer this. I want to show you the way that's probably going to help you more on your test first, but then I'll show you guys a way that you can answer this one because it's actually interesting, the actual value he wants in the table, which isn't normal. So here's how I would encourage you guys to word it. I would say, yes, f of c equals, I'm sorry, I guess we say f of x, or you could say c, it doesn't matter, equals 0 on the interval of 4 to 6 for some value of x, And once again, I'll just not be confusing to you guys. I'll just put C. I don't want to be weird and confuse you right now. We'll just stick with the same letter. All right, so yes, f of c equals 0 on the interval from 4 to 6 for some value of c, since f is continuous and goes from 2 to 0 on that interval. All right, now that's probably the better way for you guys to know how to answer this. That'll help you with your test. But I mean, now with this type of a question, it's almost kind of silly if you actually notice it, because they're asking, can it be shown, does it cross the x-axis anywhere? Well, it crosses the x-axis right here. So all I have to do is say yes, because the table shows that 6, 0, a point on the graph. Or you, instead of saying 6, 0, you could say f of 6 equals 0. Either way is fine. So, but that's one I would just answer like that on here, just because it turned out to be kind of a quirky question. But for the most part, you want to answer it the first way I showed you there. All right. And I think we'll go ahead and stop there. And well, obviously we'll stop there. There's no more questions. So anyway, hope that was helpful to you guys. And we'll see you guys later.